So welcome back to the Virtual Azure Community Day. Our next speaker is Eva Pardi. Eva, welcome. How are you?
Thank you very much. I'm feeling really good. I'm finally talking from home this time.
Okay. So you were talking from all sorts of places before, or?
Yeah, so I'm working in Denmark in general, but right now I'm in Hungary at my hometown right now. So that's really cool.
Oh, okay. Okay. So you're absolutely obsessed with data and passionate about AI. Can you tell a bit more about that? What do you do?
Yeah, in full time I'm working with healthcare, mostly using data and AI to improve the life saving for the work of nurses and doctors at different hospitals all around the world, actually. And that's my main task to do. Next to that, I'm also going out to different conferences to share some knowledge with the attendees there. And I'm also mentoring some students and try to help them how to get to the field of AI and data science.
That sounds great.
I think that's really important.
Yeah, it is. And thank you for doing that. So your session is about building trust and power with explainability. Can you tell a bit more what your session will be about?
Yes, first of all, I'm going to give a quick introduction about what is explainability and why is it important, and how Microsoft is aiming for reaching out to people to build trust towards the AI services from the people. And inside that, I'm mostly focusing on the interpretability and the natural language processing.
Okay, that sounds really cool and interesting. So go on. Good luck with your session.
Thank you. So I'm going to share my screen. So first of all, I am very, very happy that I can be here as a speaker today and that I can talk about this awesome new tool that is available for every developers. And I'm going to talk about interpret text. I'm going to give you an intro about the different tools that are available in the field of responsible machine learning. And then I'm going to show you some demo as well about the interesting tools that I prepared with. So, so we are very much seeing this as a real challenge that customers are facing, as a recent Capgemini report showed, in which 9 of 10 executives have reported facing ethical issues in the implementation of AI. These executives cited reasons including the pressure to urgently implement AI, the failure to consider ethics when constructing AI systems, and a lack of resources dedicated to ethical AI systems. So artificial intelligence, or AI systems, have a growing impact on people's lives on an everyday level. And it is fundamental to understand models, protect people, and control AI systems. While machine learning services are constantly developing, Microsoft emphasizes the ethical principles that AI develops in such a way that can be benefited in society while warranting people's trust. Before I'm going ahead, let me give you a quick introduction about myself. So I am Eva Pardi, Microsoft AI MVP, and in full time I'm working as a software developer and data scientist at Lerda, which is a company in Copenhagen in Denmark, but it is coming from Norway actually. And the aim of this company is to provide courses to nurses and doctors who are saving lives all around the world. So if you want to reach out to me, you are welcome to write me an email. You can find me on LinkedIn, Twitter, and Facebook as well. And later on, I'm going to share you my blog as well, where you can read more about the things I'm talking about today. So thank you again that I can be here. And let me go back to the topic that I brought to you now. So the object of this session is to bring explainability into often confusing and complex AI systems, since these can sometimes behave strange for various and not fully understood reasons. And the tools today that we discussed today that can help developers to debug and fully understand your models. Furthermore, these aim to increase the understanding of intelligent systems for end users as well, and building trust and power, which can assist users to make better decisions and accept AI solutions. So right now, I would like to walk you through quickly on this slide, like what you can see, because AI systems, as we said already, can behave unexpectedly for a variety of reasons. And fairness and interpretability tools can help you understand the behavior of your systems so that you can better tailor them to your needs. AI systems rely on data. And these software tools can help you protect that data by preserving privacy and ensuring confidentiality. And responsible AI needs governance and control through the development cycle. And Azure Machine Learning enables an audit trail for better traceability, lineage, and control to meet regulatory requirements. From the tools that can be used to help developers to fully understand their models, in this session, I'd like to focus on interpretability. And then after me, Willem is going to tell you about FairLearn, and that empowers developers of AI systems to assess their system's fairness and mitigate any negative impacts for groups of people, such as those defined as in terms of race, gender, age, or disability status. That is also really interesting, so I hope you won't miss it. And before that, now let me introduce you first to the other tool for understanding, interpretability. So interpretability assists data scientists to explain, debug, and validate their models, thus helping to build trust towards the model. InterpretML is an open source Microsoft package that incorporates ultra-modern machine learning interpretability techniques and can be viewed as a valid source for explaining glass box models and black box systems as well. The Azure Machine Learning Interpret package supports developers using datasets formats such as the NumPy array or Pandas data frame, and furthermore leverages libraries like Lime or Plotly and offers new interpretability algorithms as well, like the explainable boosting machine. The interpretability package can be useful for any data scientist, especially for startups or for companies, and it is a very essential tool for model debugging to understand why did your model make that kind of mistake, or you want to detect fairness issues, whether your model discriminates, or you want to use it for human AI cooperation. You know, how can I understand and trust the model's decisions? It is an essential tool as well for regulatory compliance, whether your model satisfies the legal requirements. And it is very useful for high-risk applications in healthcare, finance, or judicial services to understand the model's decisions that helps building trust amongst the stakeholders and executives. Though tabular data is standard among machine learning scenarios, natural language processing has been growing in popularity with applications in topic classifications or sentiment analysis and entailment in a wide variety of business scenarios. So, interpret text is an innovative interpretability technique for natural language processing models. It has been developed by the community and it has been announced at the Microsoft Build in this year. It currently only supports topic classification, but it is planned that the repo would include other NLP scenarios as well. And if you have any scenarios in your mind that you would like to see supported, please reach out to me and we'll try to do as much as possible for that. So this open source tool allows developers and data scientists to explain their models globally for each label or locally for each document. You can use it to build a visualization dashboard that provides insights into your data. And you can perform comparative analysis on your experiments while running them on different state-of-the-art explainers. Interpret text comes with explainers that support BERT, or bidirectional encoder representations from transformers, and RNN, as well as standard scikit-learn models. With this open source toolkit, users will be able to take advantage of the state-of-the-art interpretability techniques with a common API across integrated libraries, as well as its own visualization dashboard for understanding which key phrases and words were important to your text classification. And before looking into the different explainers, let me take a step back, because there are two broad classes on NLP approaches: the classical machine learning and the deep learning techniques. In classical techniques, the first step is preprocessing, which involves steps such as tokenization, normalization, noise removal, and so on. And then the processed data is fed into the model, which can be a logistic regression, a random forest like GBM, and so on. The output depends on the scenario you are modeling for. And for some of these approaches, the internal functionality is very well understood. And as a result, the user is confident in the explanations provided. However, these methods are widely adopted and easy to use. They are quite limited in their accuracies on the real-world datasets. But recent advancements in NLP owe a lot to developers in deep neural networks, such as BERT. And these models have high accuracies on NLP tasks. However, they are black box models, and their decisions are quite difficult to understand. And the research community, for this reason, has created a suite of this state-of-the-art interpretable models, ranging from post hoc analysis to plugins during the training. And though it is promising, these methods are hard to implement in practice and not as accessible to data scientists. Therefore, to make these recent research developments more accessible for data scientists, in this toolkit, Microsoft has released OSS implementations of 3 different explainers. They have implemented 1 classical and 2 state-of-the-art explainers that provide local explanations on text documents. So we have the classical text explainer, which is a standard set of glassbox models. We have this unified information explainer, which is a post hoc method and model agnostic. And we have the introspective rationale explainer, which is a plugin method and also model agnostic. So now let me talk a bit more about these explainers to give you a good overview of how they work. So the first one is the classical text explainer. This is an interpretability technique used on classical machine learning models and covers the whole pipeline, including text preprocessing, encoding, training, and hyperparameter tuning, all behind the scenes. And you can supply your dataset without any external procedures. And for preprocessing, it uses a bag of words encoder and logistic regression for training as a default configuration, which can actually be changed in this configuration file. As an input model, classical text explainer supports 2 model families: the scikit-learn linear models that says support for coefficient, and tree-based models. Additionally, any models with similar layout and suitability for sparse representation can be used soon. So this API enables developers to extend and move around the different modules, such as the preprocessor, the tokenizer, or the model, and the explainer still can pull in and use the tools that are implemented in this package. The explainer returns the importance of the words to show how big effect the word has on the decision the model makes. We are going to take a look at this in the demo, how does it work, and I hope it will show you and give you a better understanding of it. The next one is the Unified Information Explainer. This is one of the state-of-the-art NLP interpretability models. This explainer is a post hoc method, meaning it needs a previously trained or fine-tuned deep neural network model. Support for explaining BERT is implemented and will be extended to other deep neural networks like residual, convolutional neural networks, and LSTMs as well in the future. So this method uses a mutual information-based approach, and it provides the importance of words as it goes through all the layers of the neural network. Since each layer is explained, the explanations about the transformer, pooler, and the layers are unified and intelligible. Text preprocessing is handled by the explainer, and the sentences are tokenized by the BERT tokenizer. And about the BERT tokenizer, you can, and the whole unified information explainer, you can find some more information in the paper that I show on the slide. And if you want, I can share it also on the chat, or we give you the slides, or I'm not sure how will this work, but you will get it for sure. Anyway, the key task here is to associate underlying representations of the word with interpretable units in the hidden states of the layers. And then we want to quantify how much information of an input word is included in each layer. So a very important word will have a lot of information encoded. So there are two forces at work here. As the word embedding is going through the layers of the deep neural network, and it is perturbed by trying to add as much noise as possible. What we want to see now is how much the output changes as the noise is added. So if a lot of noise affects the output, then it is an important word for that layer. If it doesn't affect the word, then it is not important. Then, on the other hand, the loss function tries to minimize the difference between the perturbed hidden state and the original hidden state, since we don't want to end up explaining a different model by perturbing it too much. So these two functions work hand in hand to help us better understand how the words are being propagated through the layers of the neural network. So there is this repo here where you can find the sample notebook as well, and I'm going to show you that too. And we will walk through the code as well in the demo. How does it work? And inside this, it uses the multi-label text classification scenario as an illustration. The introspective rational explainer is the third state-of-the-art explainer. More details about the method are in the paper that you can see down here, but let me give you a brief introduction about this as well. So this method introduces a plugin into the training process and makes the black box model more interpretable. This plugin is called the Introspective generator. This introspective generator splits the text into rationals and anti-rationals, and then the rationals are a subset of the words that, according to the introspective generator, are important. And then, on the other hand, the anti-rationals are not important, according to the introspective generator. Then, the introspective generator simultaneously trains the model on both the rationals and anti-rationals, and it tries to maximize the accuracy of the model when only using the rationals, and on the contrary, minimizes the accuracy when using anti-rationals. So, since the model only sees the rationals at training time to make the prediction, strong guarantees are provided about which phrases matter to the prediction. So generally, no other method provides such strong guarantees like this one. So this API is designed to be modular as well and extensible, and can be used when a BERT or an RNN model needs to be explained. If the developer wants to define a personalized model, then the preprocessor, the predictor, and the generator modules has to be provided by the developer. So let's compare these explanation methods. So when you want to decide between these explainers for your use case, we recommend using the classical text explainer when using more classical machine learning models for natural language processing. And when you don't want to deal with the natural language processing pipeline, since it is quite simple to move components around with this classical explainer. However, when you need to understand neural networks, I recommend either the unified information explainer, which allows you to understand information as it propagates through the layers, or the introspective rational explainer, which provides strong guarantees on which phrases contribute towards your prediction. So right now we walked through on the basics of these explainers, and I think it is time to switch over to our demo where I'm showing you all these explainers so you have a good understanding how these work and how can you use it for your own scenario. So I'm switching over to the demo. And the name of the explainer that I want to walk you through first is called the classical text explainer. This is, as a reminder, I'm just going through on this again. This is an interpretability technique used on classical machine learning models and covers the whole pipeline, including the text processing, the encoding, the training, and hyperparameter tuning as well behind the scenes. And for encoding, it uses the bag-of-words encoder, and for training, is using the logistic regression as a default model. Now, and also as a quick reminder, as an input model, you can use two model families, the scikit-learn linear models and the tree-based models. All right, now let's see how can we use this explainer. Right now, I am using my local computer and Jupyter notebooks installed on it. And as you can see in the first cell, I prepare the environment and define the working directory. Then here the data is imported. And thanks to pandas and this built-in function, we can work with the data as a data frame. And the data frame looks now something like this. I'm just showing to you like this. And what we want to do is to predict for each sentence what is the genre of that sentence. Right. So for this, I also made a data frame for my features, so for my sentences, and also for my labels for the genre. Now, just for fun, let's take a closer look in the labels. So what kind of labels we have. So if you run this code, you can see that we have these kind of labels, and we can see how many examples we have for each of the labels. And we can also see that the data is nicely balanced. So it is really good because the model gets a similar number of examples for each genre. So the predicted result won't be that skewed either. And as mentioned before, the classical text explainer takes care of the entire pipeline, and the label encoder of sklearn is going to be used for preprocessing. Now, it is time to split the dataset for training and testing with the use of this train test split function of sklearn, and the label encoder is going to help us with it. And in the end, we can see that we have 104,000 rows for training and 26,000 rows for testing. Okay. Now we are ready for training. And explainer's fit function is actually doing the training for us. And it is going to return us the classifier and the best parameters as well. And what we can see here in the pipeline configuration, that it includes the preprocessor and the classifier as well. And please note that it is holding here the logistic regression default model that we use, and the best parameters are taken from this list here. And you have to remember that this configuration is built from the data set and the model that we specified for this run. So it might not perform on the same way with a different configuration, of course, and that you can choose a different model too, and that you only have to define it in a configuration file for your run. So after training, we can score our model. And with the use of the test dataset, the labels now can be predicted. And as a result, the accuracy, the precision, the recall, the F-score can be returned. And here we can see that it is quite okay. It is 84% sure about the decision it made. But how our model could figure out the genre? Like, how does it choose the important ones, the important features from the list that I gave it? So what we want to do now is to test and explain the model and explain the decision it makes. And for that, the first step that I will do is to pull in the possible labels into the explainer. And then we explain the prediction locally about the specific string. And for this step, I chose data from the data set we trained the model with, and I'm going to show you. So we are going with this sentence, and what we want is this genre to be returned. So I just go back. There. And the local explanation, it's like this explain local function. It could hold more parameters. Microsoft is working very hard on that to make that happen, because you can explain this sentence by itself, and then it explains the chosen label from this list. Or you can define whether this sentence is closer or further away from another label that we have as an option here. So what we need to do here is to take a look what this function returns. We can see the list of labels, as I mentioned before, and it also make some ranking on the words we pass it as a feature. And as a result, we could show the words and the values. And what this shows us is the words that was coming from the sentence we gave it in an order that is, first is the most important word, and then the less important ones after it. And then here the values showing how important is that word and whether it is not important at all. And as you can see, it is also in an order, the same order like how the words are. And just for fun, I also want to show you that actually the prediction also works, that we have the text, the actual label, and the predicted label as well. This is pretty cool, and we can see some numbers, and it makes some sense that, okay, these words are the most important ones for this prediction. But it is not really easy to understand from just numbers, like what is actually happening here. So for this, it is very handy to use the explanation dashboard. This is an interactive widget that shows whether the specific word has an effect on the prediction, whether it is a positive feature, so has an effect on the prediction, or a negative feature if it does not. It actually somewhat has effect on the prediction, but it is leaning the decision towards another other label. So you can generate this widget basically with these 2 lines of code. And then we can see such a thing here. So with the slider on the top of the dashboard, the number of important words can be set that you want to see. And on the right side, you can see what is the predicted label. And under that, you can also choose whether you want to see only the positive ones or only the negative features. For this sentence, we don't have negative features, which is pretty cool. It means that most of those words that are in the sentence are actually leading the decision towards the government label. You can also hover over the bars, and you can see the same values that we got previously from the list that I showed you. All right, so yes, and I mentioned here that it is showing you the predicted label. And here I want to mention that because this is under hardcore development as well, that we expect that at some point we will be able to explain this sentence for another label as well. So it will show us whether, for example, that sentence could be predicted as a telephone label, and then it shows which words are leading towards the telephone label or not for that one. I hope it made sense. And just for fun, to show you that it actually works, and it works with the data that is not from the data set, I prepared a bit of fun for you here. So I have a sentence here. We had a great time at your party yesterday. Thank you a lot for the invitation. And what I could do, and I hope it will work, is that I'm going to put it and give it to the explainer, and I'm going to explain it locally, so only this sentence. And I'm going to show you again what are the labels the machine can choose from. And I would like you to put it in the comment section or somewhere. What do you think this sentence will be predicted as? So what is the label for this sentence in your opinion? And I'm waiting just a tiny bit so you have time to put in your votes. And then I'm going to run the next code, which is actually giving you the predicted label that is the opinion of my machine. So when you are done, I'm going to just press the button. So I'm not sure which one did you choose, but my machine says it's slate. This is really interesting because every time I ran this code before, it always came back with telephone, actually. This time it didn't. This is how fun is the live demo, right? But we can see that a well-trained machine is still able to make a different decision. This is why it is good to see why did it make that decision. So you can see in the dashboard that, okay, it seems like that some of the words, there are some negative features as well that is leading away from the slate label. There are some that is leading it towards the slate label. All right, but the point is that with the use of the classical text explainer, it is quite smooth and quick to put together a training pipeline, and the evaluation of the model is more straightforward and understandable. And the users also get a good overview of how the model uses the data that is provided. And this allows us to improve the pipeline easier. And note that it is an open source code, and you are welcome to try it out and go and play with it. You can see the GitHub code on the bottom of the page. But let's continue because we have two other explainers as well that we can talk about. The next one is the Unified Information Explainer. And it can be used when a unified and intelligible explanation is needed about the transformer, the pooler, and the classification layers as well of a particular deep neural language processing model. So text preprocessing is handled by the explainer, and the sentences are tokenized by the BERT tokenizer. Right, the developer must provide the Unified Information Explainer a trained or fine-tuned BERT model with samples of trained data. And the support for RNN and LSTM is going to arrive soon, and we can play with that soon as well, finally. So again, the notebook environment and the working directory is defined with this code snippet, and some variables are also defined that will be used for training. It is possible to decrease the runtime by setting this quick run to true, but note that it is going to affect the performance of the model, so it will be much weaker because of this. Yes, I'm going to tell you more later about what would happen if it is not true. But let's move on with the other parts of it. Additionally, yes, the batch size can be set based on the configuration of the device where you run your code. You can use this is available code of PyTorch to define it. Right. For this demo, I used the same data set as previously. So the idea is, again, find the genre for the sentence. But what I want to show now is something more interesting. Again, a balanced data set. And the data is now going to be splitted with the use of the train test split again. Right? And the label encoder of the sklearn is going to be used for text preprocessing. And if the quick run is true, it is possible to pass only a fragment of the entire data set that has been defined on the beginning of the notebook, like this as well. And this will maybe reduce the performance of the model, but after running this transformation, we can review the number of labels that we are working with, how many training examples we have, and how many testing examples we have. This is obviously a demo version, and that is not, maybe it's not going to perform very well, but it's just good enough for now. So before passing the data to the model for training, it has to be prepared for tokenizing as well. And for this task, the BERT tokenizer can be used for both the training and the testing data sets. Right. And then after these processing steps, the model will receive the data as a list of tokens. And in these two lines here, some extra pre-processing is done, such as specifying the beginning and the end of the sentence, the token length, this max length. You can change it if you want to decrease the training process length. And you can find more about the BERT tokenizer on this link. I will share this with you as well. Cool. So the next step is to load the pre-trained BERT model with the use of this sequence classifier. We can specify the number of labels, the language, and here we do the training with the use of the tokenized data, the defined batch size, and the number of epochs. And remember, these variables were also defined in the beginning of the notebook. So this step also involves fine-tuning of the BERT and the BERT transformer and the learning linear classification layer on top of that also added. Right, and the classifier is now ready to score the data set. So the scoring is done here. And then here we can come back with the accuracy report. And we can see the different scores, how the accuracy looks like, and so on. You can see all kind of information that we might want to understand. And we can also see that which label returns with how good accuracy and how good results. Okay. So it is very important to understand what happens behind the scenes, how the model decides based on the different words, which label to assign to the sentence. And the following code example here would return the configuration details for each layers of the classification model. And you can see there are all kind of important information for each layer, basically. And then to get an explanation of the model, the Unified Information Explainer needs to be initialized by passing the model, the dataset, and the CUDA device, and the target BERT layer. And remember, I told you that you are allowed to explain all the layers you have, right? All the different layers that you want to know more about. And then the prediction step is made on this data set. And then the explainer is called on it. Now you can see that my demo was not finished before I got to start my session, but let's come back to this later. What we expect is a similar dashboard that we looked at in the classical explainer. The difference here is really just that it is used for deep neural networks, deep natural language processing models, and it works really well when you want to understand what happens on each of your layers. And now I would like to show you another scenario with an explainer that is also working with deep natural language processing models. And in this case, I brought you a different data set. And this data holds opinions about different movies, concerts, and so on. And we want to see and analyze the sentiment of these comments. And again, as a reminder, let me walk you through again what are you going to see now. So to generate and understand a text fragment of important features for training a classification model, that's when you want to use the Introspective Rationale explainer, because this uses a generator predictor framework. And this tool predicts the labels and organizes the results, whether the words are useful, rationals, or should not be used for training, anti-rationals, which anti-rationals are filtered out before the training as well. And the API is designed to be modular and extensible and can be used when you work with a BERT or an RNN model that has to be explained. And if the developer wants to define a personalized model, then the preprocessor, the predictor, and the generator modules should be provided by the developer. Okay, so the notebook environment is defined here, and then some configurations and the working directory is defined, yes. And it is possible again to decrease the runtime with this quick run setup here. And then again, remember, this is affecting the performance, and it keeps over embedding and most of the evaluation as well. So it's maybe you want to try and use without the quick run sometimes, well, in real-time environment, in real-life environment, sorry. So the next step is to import a data set. For training, and we use this predefined function that again extracts the data and builds a pandas data frame of it, which is now ready to use. And some data sets are defined here that will be used for training and testing. And now the model configuration is updated with the labels and the number of labels. And now let's review the data and the labels we have. So the data looks like this. So we have sentences and the labels for them. And again, we can take a look at the labels here, and we see that it is kind of balanced. So we could expect quite okay results in the end. So the global vectors for word representation. This is a preprocessor. This will tokenize and empt the data. And then the labels then get appended to the output of the tokenizer. So then the trained data will look like this. It's beautiful, right? And then as the next step, the explainer is initialized down here. And the preprocessor is set up. So initialization preprocessor. And then the model configuration is also passed to the explainer, and the training can start. The aim of this classifier again is to identify the sentiment of each sentences. Yes, and as a result of this code, the details of the model can be reviewed. And it also returns the configuration details for each layers of the classification model. And after our accuracy is not very good with the quick run. But after the prediction, we can return the accuracy of our model. And it is again very important to understand what is happening behind the scenes, how the model decides so whether it is 0 or 1. So now we want to do is that we want to explain this sentence. A beautiful and haunting examination of the stories we tell ourselves to make sense of the mundane horrors of the world. It sounds like it's a very positive sentence, sort of. And again, we can return the words, whether it is important and all that. And I just want to run this because I want to see how this looks. Oh, I did incorrectly, sorry. So words. And then also the values. Okay. So as you can see, it seems like most of the importance is the same, and it is above 0. Do you remember why is that? It's because before the training, our explainer thrown out all the negative features. So it kept only the positive ones that has effect actually to get a good accuracy. And then this dashboard here also returns only the positive features, and it doesn't have negative features at all. So again, when you use a quick run, the model sometimes does not train very well, which returns odd results. So for real-world scenarios, you might want to use real run with both the deep natural language processing models and the explainers for them. So for the unified and the introspect ones too. So now I move back to my slides, and let's see. So again, when you want to decide between the different explainer for your NLP model, you can use the classical text explainer when using more classical machine learning models for natural language processing. And when you need to understand neural networks, I recommend either the Unified Information Explorer or the Introspective Rationale explainer. And as I said in this session earlier, this is an open source toolkit. So we welcome contributions. You can find the link here for the GitHub repo. And please check it out and then take a look at the other additional resources on both Microsoft Responsible AI Resource Center and Interpretability as well. And if you have any questions, I am ready to answer your questions now. And oh yes, and it's very important, if you have anything that you go and try it out by yourself and you find anything that is doesn't make sense, then feel free to reach out to me personally.
Thank you so much for this session. Now I can understand that this is a pretty advanced topic, and well, just like me, maybe other people are also very interested in this, but it seems quite difficult to start. Do you have any tips where I can start learning more?
Yes, and I almost forgot to say it, that I would be very happy if you could go and look at my blog for this. I'm just going to share my screen again and show it to you very carefully. Because I have my blog here, websites.net, where you can find all my notes and everything about this topic. And I keep improving it, like every day when I have some time I go and make some changes on it, so you will find always updated content. And
cool.
Maybe this is where you could start.
Cool, so
and
I
of
shared
course the GitHub repository I shared you just now.
Cool, I shared the link to your blog in the chat, so well, be sure to check it out if you think, hey, this is mighty interesting, and learn from all your notes. That must be a lot of work.
Yeah, sure. I'll share it, of course.
Okay, cool. So I've seen you on social media chatting about global AI community.
Yes.
Can you explain more what this is?
So the global AI community is a bunch of cool people who are aiming for reaching out to more and more people and spread the knowledge about AI, and try to bring always up to date and the newest releases and such things to people who are interested in the field of AI.
Cool.
And I'm actually pretty new in this team, but I'm very happy that I can be part of it because we are doing some awesome stuff. For example, next time in, I think it is in October 7, we have another 30 hours long event with all kind of awesome sessions. So, yes.
Okay, cool. So where can people find more information on this event?
About the global AI community?
Yes.
You can go to, I can share that as well. So it's globalai.community, the page where you can reach this community, and you can reach out to us as well from there.
Okay. Well, thank you very much.
You can find all the events here as well.
Thank you very much. I'm sure that we will share the link to the global AI community in the chat as well, and of course on Twitter. By the way, if you enjoy this event, please tweet about it using hashtag VACD, making it quite simple, so you have more space for your interesting things you want to share. Well, thank you very much for your talk. We really enjoyed it, and I'm looking forward to learn more during the Global AI Community event in October.
Yes,
so,
thank you as well.
Good. So there's one more thing I would like to bring to your attention. That is, you've seen the cute badger, which we show around break time each time. This badger is a collectible based on blockchain, and it's our community rewards program. Now, for each thing you do in the community, you can earn a badge, for instance, by joining an event, but also by being a mentor or an inclusive leader, and you can also nominate other people for this. You can find more information on this on aka.ms/azure.heroes. That's aka.ms/azure.heroes. And there you can discover what kind of badges are there to be rewarded or to reward someone else for this. So it's a very good way to recognize all your friends in the community who play an important part there. The Summer Learner Badge, you can only get this during this summer. So scan the QR code if you want one, because well, in September then they will it won't be possible to get one again. So we're going off for a short break, and then Willem Mijns will start his session about further. So stay tuned and be right back.
大家好
Kamusta?
Servus.
Hi.
Hi.
Bonjour.
Jasas.
Hi.
Hoi. Ik ben
I'm
Floor.
Introspective from Austria.
日本からこんにちは。私は桑高之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schot uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, kamusta? I'm Ruby Jane Cabagna from the Philippines.
Hola.
Hello.
Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Charlene from France.
Hello, I'm Ruth from France.
שלום. אני ערן סטילר מישראל.
from the Netherlands.
Bonjour, I'm Olivier from.
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.
大家好
Servus.
Hi.
Hi.
Bonjour.
Jasas.
Hi.
Hoi. Ik ben
I'm
Floor.
Introspective from Austria.
日本からこんにちは。私は桑高之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schot uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, kamusta? I'm Ruby Jane Cabagna from the Philippines.
Hola.
Hello. Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Charlene from France.
Hello, I'm Ruth from France.
שלום. אני ערן
I'm
סטילר
Susanne
מישראל.
from the Netherlands.
Bonjour, I'm Olivier from.
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special.
the Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.
大家好。
¿Cómo está?
Servus.
Hi.
Hi.
Bonjour.
Gracias.
Hi.
Hoi, ik ben
I'm
Floor.
Introspective from Austria.
日本からこんにちは。私は桑田孝之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schont uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, ¿cómo está? I'm Ruby Jane Cabagna from the Philippines.
Hola.
Hello.
Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Charlene from France.
Hello, I'm Ruth from France.
שלום, אני ערן ספילר, מישראל.
Bonjour, I'm Olivier from
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.
大家好。
Servus.
Hi.
Hi.
Bonjour.
Gracias.
Hi.
Hoi, ik ben
I'm
Floor.
Introspective from Austria.
日本からこんにちは。私は桑田孝之です。
Ciao, sono Stefano Tempesta, dall'Australia.
Hallo, ik ben Albert Schont uit Nederland.
Hi, I'm Maarten Goed from the Netherlands.
Hi, ¿cómo está? I'm Ruby Jane Cabagna from the Philippines.
Hola.
Hello.
Hey there.
Hola, soy Sebastián Pérez de Argentina.
你好，
Desde
我是
España.
胡浩，来自中国上海。
Hi, I'm Sarah Lane from Scotland.
Bonjour, I'm Charlene from France.
Hello, I'm Ruth from France.
שלום, אני ערן ספילר, מישראל.
Bonjour, I'm Olivier from
Hi, I'm Gilbert Villiers of Gold Coast, Australia.
For everyone who is upskilling this staycation, we have something very special. The Summer Learner Badger, and you can earn one for joining this event. Scan the QR code, which will appear on your screen, and claim your badger. Azure Heroes is a Microsoft program for recognizing community efforts.